Okay, this problem. A man is at rest on a sled, and they give us the mass. He fires a rocket which does 1,400 joules of work on him. What is his final velocity? Okay, so final velocity indicates we're probably going to be going to find the final kinetic energy. Ignore friction and air resistance. Now, normally when you see ignore friction and air resistance, you should be really suspicious about work being zero. In this situation, they straight up told you the work was not zero. So just think of them as making sure that there's no other factors, no other work kind of going into this. Hopefully that doesn't confuse you. So Ki, he's originally at rest, gone, okay? The initial potential, he's on the level ground, it says in the problem, it's gone. And the work is 1,400 joules, so we got 1,400 joules equals, we don't know it's his final kinetic energy, that's what we want to find, plus potential final is still zero actually, because he's still on level ground. So that was, wow, that was easy. The kinetic final is just 1,400 joules. Sweet. So now we're going to go and we're going to say, okay, K is equal to mv squared divided by 2. So K is 1,400 equals, our mass is 78, velocity squared divided by 2. You can do this lots of different ways. Let's just do the 78 divided by 2, and that gets us 39v squared equals 1,400. You could have also multiplied up the 2. I'm totally okay with that. Works either way. So we're going to do 1,400 divided by 39. So 1,400 divided by 39. Oops. Okay. And get 35.9 equals v squared. And now you got to take the square root of the other side. 35.9. Now we get us our velocity. So the velocity of this dude bombing along is, drum roll please, 6 meters per second. So really not exactly the most powerful rocket. Not so much a blast of fire as like a teeny little splurt of fire. I hope that doesn't look like it's coming out of his butt. Okay, have a nice day.